This is the top 10 most asked questions in general chemistry. Here's a list of the 10 question topics with timestamps. Pause the video now and you can skip to the ones that interest you. Number 10. What is the ideal gas law and how is it applied? The ideal gas law, represented by the equation PV equals nRT, accurately describes the behavior of many common gases under typical conditions. It connects the pressure P, volume V, amount of substance N, and temperature in a gas. This formula is particularly useful for calculating any unknown variable when the other three are known, simply by rearranging the equation. Additionally, it's invaluable for examining changes in gases' states. If one variable is altered while the others remain constant, the law can predict the effects on the remaining variables. The law is also applicable to gas mixtures requiring calculations that take into account the total pressure, volume, and moles of the combined gases. Number 9. How do solutions form and what factors affect solubility? Solutions form when one or more substances, solutes, dissolve in another substance, solvent, to create a homogeneous mixture. This process occurs when the intermolecular forces between the solute and solvent overcome the forces holding the solute particles together. The resulting mixture has the same properties throughout and can be in the form of a gas, liquid, or solid solution. Factors that affect solubility include nature of the solvent and solute, like dissolves like, temperature, as temperature increases, solid solubility increases and gas solubility decreases, pressure, as pressure increases, solubility increases, surface area of solutes, directly proportional, stirring and chemical nature, such as forming hydrates. Here's an in-depth view of the specific factors. Nature of the solvent and solute. Different solvents have varying abilities to dissolve different solutes. For example, polar solvents like water tend to dissolve polar solutes, while nonpolar solvents dissolve nonpolar solutes. Similarly, the polarity, size, and shape of solute molecules influence their solubility in a given solvent. Temperature. In general, as temperature increases, the solubility of solid solutes in liquids also increases. Exceptions exist. However, the solubility of gases in liquids typically decrease with increasing temperature. This is because higher temperatures provide more kinetic energy to break intermolecular forces and allow solute particles to dissolve for solids or escape from solution for gases. Pressure. Pressure affects the solubility of gases and liquids but has little effect on the solubility of solids and liquids or liquids and liquids. Henry's law states that the solubility of a gas in a liquid is directly proportional to the partial pressure of that gas above the liquid. Therefore, increasing pressure increases the solubility of gases and liquids. Surface area. For solid solutes, increasing the surface area exposed to the solvent typically increases the rate of dissolution because it provides more contact between the solute and solvent molecules. Stirring. Stirring a solution increases the rate of dissolution by ensuring fresh solvent continually comes into contact with the solute, thus speeding up the process of solute particles dispersing into the solvent. Chemical nature. The chemical nature both of the solute and solvent, including any chemical reactions that may occur between them, can affect solubility. Some solutes form ions or hydrates in solution, altering their solubility characteristics. Hydrates are compounds, typically crystalline in nature, that contain water molecules bound within their structure. These water molecules are not just physically mixed into the compound, but are integral to its molecular framework, often bound to a host molecule through coordination links or hydrogen bonds. An example of a hydrate is creatine monohydrate, a popular workout supplement. Number 8. What are the states of matter and how do changes between states occur? The states of matter are the distinct forms that different phases of matter can take based on their physical properties and arrangements of particles. The most common states of matter are solids, liquid, gases, and plasma. In a solid, particles are closely packed together in a regular arrangement. They have a fixed shape and volume. Solids resist compression and have strong intermolecular forces holding their particles together. In a liquid, particles are still close together but can move past each other more freely than in a solid. Liquids have a fixed volume but take the shape of their container. They flow and are less resistant to compression than solids. In a gas, particles are much farther apart and move freely, filling the entire volume of their container. Gases have neither fixed shape nor volume and are highly compressible. They exert pressure on the walls of their container due to the collisions between the particles and their container walls. Changes between these states of matter occur through the addition or removal of energy. The main processes involved in these changes are melting, solid to liquid, freezing, liquid to solid, vaporization, liquid to gas, condensation, gas to liquid, sublimation, solid to gas, and deposition, gas to solid. Melting occurs when a solid gains enough thermal energy heat to overcome the intermolecular forces holding its particles together. As these forces weaken, the particles gain enough freedom of movement to transition into the liquid state. Freezing is the reverse process of melting. It occurs when a liquid loses enough thermal energy for its particles to arrange themselves into a more ordered, solid structure. Vaporization includes both evaporation and boiling. Evaporation is the gradual conversion of a liquid to gas at the surface of the liquid, while boiling is the rapid conversion of liquid to gas through its entire volume of the liquid, usually accompanied by the formation of bubbles. Condensation is the opposite of vaporization. It occurs when a gas loses enough thermal energy to transition into its liquid state. This typically happens when gas molecules come into contact with a cooler surface or when gas is cooled. Sublimation is the process by which solid directly transitions into a gas by passing through the liquid state. It occurs when vapor pressure of the solid exceeds atmospheric pressure at a given temperature. Deposition is the reverse of sublimation. It occurs when a gas transitions directly into a solid without passing through the liquid state. This typically happens when a gas loses thermal energy rapidly, causing its particles to come together and form a solid. Number 7. What are the main types of chemical bonds? The main types of chemical bonds are ionic and covalent bonds. The ionic bonds form between atoms when one atom transfers one or more electrons to another atom, resulting in the formation of ions with opposite charges. These ions are held together by electrostatic forces of attraction. Ionic bonds typically occur between a metal and a nonmetal. For example, with magnesium oxide, MgO, magnesium transfers 2 electrons to oxygen to form Mg2+ and O2- ions, which combine to form the ionic compound magnesium oxide. Covalent bonds form when atoms share electron pairs of electrons to achieve a stable electron configuration. For example, with water H2O, each of the 2 hydrogen atoms share a pair of electrons with the central oxygen atom, resulting in 2 covalent bonds and the formation of the H2O molecule. Covalent bonds can be further categorized as single, double, or triple bonds based on the number of electron pairs shared. Number 6. How do you determine the molar mass of a compound? To determine the molar mass of a compound, you add up the atomic masses of all the atoms in the compound, taking into account the number of each type of atom present. First, you identify the chemical formula of the compound to determine the types and numbers of elements present in the compound. Next, look up the atomic masses by consulting the periodic table. The atomic mass is the number with the decimals by the element of interest. Lastly, multiply the atomic mass of each element by the number of atoms present and add up the masses. This total gives the molar mass of the compound in grams per mole. For example, let's calculate the molar mass of alcohol, ethanol, C2H5OH. First, you identify the chemical formula to determine the types and numbers of elements present. Alcohol has 2 carbon atoms, C, 6 hydrogen atoms, H, and 1 oxygen atom, O. Next, look up the atomic masses from the periodic table. Carbon C has an atomic mass of approximately 12.011 grams per mole. Hydrogen H has an atomic mass of approximately 1.008 grams per mole. Oxygen O has an atomic mass of approximately 15.999 grams per mole. Last, multiply the atomic mass of each element by the number of atoms present and add up the masses. Carbon, 2 times 12.011 grams per mole equals 24.022 grams per mole, plus hydrogen, 6 times 1.008 grams per mole equals 6.048 grams per mole, plus oxygen, 1 times 15.999 grams per mole equals 15.999 grams per mole. All of this added equals 46.069 grams per mole. So the molar mass of ethanol, C2H5OH, is approximately 46.069 grams per mole. Number 5. What are oxidation and reduction reactions? Oxidation and reduction reactions, known as redox reactions, involve the transfer of electrons between reactants. The best way to remember the transfer is through the mnemonic oil rig, where oxidation is loss and reduction is gain of electrons. The oxidation and loss of 1 or more electrons by a substance results in an increase in its oxidation state or oxidation number. The substance that undergoes oxidation is called the reducing agent because it causes the reduction, gain of electrons, of another substance. Reduction, the gain of 1 or more electrons by a substance, results in a decrease in its oxidation state. The substance that undergoes reduction is called the oxidizing agent because it causes the oxidation of another substance. It's important to note that oxidation and reduction always occur together. When one substance is oxidized, another substance must be reduced, and vice versa. This exchange of electrons allows for the transfer of energy and drives many chemical processes, including those essential for life such as cellular respiration and photosynthesis. Number 4, what is the periodic table and how is it organized? The periodic table is a tabular arrangement of chemical elements organized based on their atomic number, electron configuration, and recurring chemical properties. It provides a systematic way to categorize and display the elements, allowing scientists to understand their relationship and predict their behaviors. The periodic table is organized by rows called periods, columns called groups, blocks, main groups, transition metals, inner transition metals, and by periodic trends such as atomic radius, ionization energy, and electronegativity. Here's a detailed look of the organization. The periodic table is divided into rows called periods. Each period represents a new energy level or shell for the electrons of the elements within that row. There are a total of 7 periods in the periodic table. The elements in the periodic table are arranged in columns called groups or families. Elements within the same group have similar chemical properties because they have the same number of valence electrons, which determines their reactivity and chemical behavior. There are 18 groups in the periodic table. The periodic table is further divided into blocks based on the subshell in which the highest energy electrons reside. These blocks are labeled as S block, P block, D block, and F block. The elements in groups 1A, 2A, and 3A to 8A are known as the main group elements. They are found in the S block and P block of the periodic table and include both metals and nonmetals. The transition metals are located in groups 3 to 12 and are found in the D block. These elements have partially filled d orbitals and exhibit a wide range of chemical properties. The inner transition metals, also known as the lanthanides and actinides, are located in the bottom of the periodic table. They are found in the F block and are characterized by the filling of f orbitals. Various properties of elements such as atomic radius, ionization energy, and electronegativity exhibit periodic trends across the rows and columns of the periodic table. These trends provide valuable insights into the behavior of elements and their compounds. In the periodic table, atomic radius generally increases across a period from right to left due to a decreasing number of protons pulling electrons closer to the nucleus. Additionally, atomic radius increases down a group as additional electron shells are added, which increases the distance between the outermost electrons and the nucleus. Ionization energy is the amount of energy required to remove an electron from an atom or ion. It tends to increase across a period from left to right due to the increasing number of protons, which strengthens the positive charge, increasing the attraction of the electrons. It decreases down a group as the outer electrons are further from the nucleus, shielded by more inner electron shells, which reduces the effective nuclear charge experienced by these outer electrons, making them easier to remove. Electronegativity is a measure of the tendency of an atom to attract a bonding pair of electrons towards itself when it is chemically bonded to another atom. It increases across a period from left to right due to more protons, which effectively attracts the bonding electrons more strongly. It decreases down a group because the addition of electron shells places the outer electrons farther from the nucleus, reducing the effective nuclear attraction on those electrons involved in bonding. Number 3. What are acids and bases and how are they defined by different theories? The Bronsted-Lowry theory defines acids and bases in terms of protons. An acid is a substance that donates a proton H+ to another substance. A base is a substance that accepts a proton H+ from another substance. In this theory, water can act as both an acid, donating a proton to form OH-, and a base, accepting a proton to form H3O+. The Lewis theory defines acids and bases in terms of electron pairs. An acid is a substance that accepts an electron pair, and a base is a substance that donates an electron pair. This theory is more general than the Bronsted-Lowry theory because it does not require the presence of protons. For example, in the reaction between boron trifluoride BF3 and ammonia NH3, BF3 acts as Lewis acid by accepting an electron pair from NH3, which acts as a Lewis base. Number 2, how do you balance a chemical equation? Balancing a chemical equation involves ensuring the number of atoms for each element is equal on both sides of the equation. This is crucial due to the law of conservation of mass, which states that mass cannot be created or destroyed in a chemical reaction. First, you write the unbalanced chemical equation, including all reactants and products. Next, balance the atoms one at a time, starting first with the atoms that appear only once on each side of the equation. Use coefficients, whole numbers placed in front of the chemical formulas, to balance the equation. You cannot change subscripts. This would change the identity of the compounds. If necessary, divide all coefficients by their greatest common divisor to simplify them to the smallest whole numbers possible. Finally, double-check your balanced equation to ensure that the number of atoms of each element is the same on both sides. Let's do a detailed balance of the chemical equation for the combustion of ethanol C2H5OH to form carbon dioxide CO2 and water H2O. The unbalanced chemical equation is C2H5OH plus O2 going to CO2 plus H2O. Start first with carbon since it appears once on each side of the equation. There are 2 carbons on the left side from ethanol and 1 on the right from carbon dioxide, so you must add a 2 coefficient in front of the CO2 to make 2 on both sides and get C2H5OH plus O2 going to 2CO2 plus H2O. Next, the hydrogen atoms, since they also technically appear once on each side of the equation. The left side has 6 hydrogens from ethanol and the right has 2 from water, so you must add a 3 coefficient in front of the H2O to make 6 hydrogens on each side and get C2H5OH plus O2 going to 2CO2 plus 3H2O. Lastly, the oxygen atoms. The left side has 3, 1 from ethanol and 2 from oxygen. The right has 7, 4 from 2O2 and 3 from 3H2O. Therefore, we need 4 more oxygens on the left, which we can only get by adding the coefficient of 3 in front of the O2 to get C2H5OH plus 3O2 going to 2CO2 plus 3H2O. Double checking, we see that for carbon, ethanol has 2 carbon atoms on the left side. There are 2 CO2 molecules, each with 1 carbon atom, totaling 2 carbon atoms on the right side, so carbon is balanced. For hydrogen, ethanol has 6 hydrogen atoms on the left, and there are 3 H2O molecules, each with 2 hydrogen atoms, totaling 6 atoms on the right side, so hydrogen is balanced. For oxygen, on the left side, ethanol contributes 1 oxygen atom, and the 3 O2 molecules contribute 6 oxygen atoms, giving a total of 7 oxygen atoms. The right has 2 CO2 molecules, 4 oxygen atoms, and 3 H2O molecules, 3 oxygen atoms, totaling 7 oxygen atoms. Therefore, the equation is balanced correctly for all elements. Number 1. What is the difference between an atom and a molecule? The main difference between an atom and a molecule lies in their composition and structure. An atom is the smallest unit of an element that retains the chemical properties of that element. It consists of a nucleus containing protons and neutrons surrounded by a cloud of electrons. Atoms of different elements have different numbers of protons in their nuclei, which determines their identity. Examples of atoms include hydrogen H, oxygen O, and carbon C. A molecule is a group of 2 or more atoms held together by chemical bonds. It represents the smallest unit of a compound that retains the properties of that compound. Molecules can consist of atoms of the same element, diatomic molecules like H2O and O2. Or different elements, polyatomic compound molecules like water, H2O, carbon dioxide, CO2, and methanol, CH3OH. The atoms in a molecule are bonded together by covalent bonds where they share pairs of electrons. Thank you for watching, and I hope these explanations help. If you have any further questions, feel free to ask, and if you found value in this video, please like it, subscribe, and let people know about the channel because it really does help spread the knowledge.